for us to look together at one of the other tutorials. There's a ton of them, obviously, for platformers and stuff like that. But in particular, I want to look at this one so we can start talking about one of the sort of fundamental principles of a lot of different programming nowadays, which is to say stuff that's called object-oriented. And this one in particular sort of gives a good structure to motivate this sort of object-orientedness. Okay, so the basic idea is we want to create a game that's kind of like Galaga, right? Where you've got your spaceship and there's enemy spaceships and you can shoot, and there's like asteroids or whatever that can fall. And you see at the bottom of the spaceship, there's that little yellow bar that's counting down. In this particular game, I don't think Classic Galaga did this, but you have like a fuel meter, and there's fuel power-ups that will add fuel back to your meter. But you could like imagine also having like a health or an ammunition or something like that. And in this particular case, it's visually demonstrated with the little bar, but obviously it doesn't have to be the bar. We can make it kind of whatever we want. So we could make it, like having numbers up at the top or something else like that as a sort of a status indicator. Okay, anyway, so that's sort of the idea of what we want to do here. So let's kind of get to it. And so just kind of follow along here, and we'll kind of talk about each step as we go. Okay, so some of the beginning stuff is going to be really easy. So, for example, set the background image, right? So this is under Scene and Set Background Image, and then we'll click there and go to Gallery, and then pick the Galaxy background, which is what, this one? Oh, right, because it's a custom one. Okay. Right, so we'll just throw that in there. And great. So all that's going to do, right, is just set the background to whatever. And on the subject, right, you've got the editor here where you can, make your own stuff. And then under My Assets, right, you've got, in this case, they've preloaded it with all of the different assets that we're going to need in this particular game. And then the gallery, of course, has stuff that's sort of predefined and built in. So, when you're just prototyping something, for example, it can be handy to just use some drop-in art that they've given to you. Okay, and I don't know how many of you guys are like pretty good with like Photoshop or something, right? So you could kind of make your own stuff if you've got that sort of artistic talent. Although, if we kind of go back here, right, notice that we're looking at super low res, very limited color palette, sort of deliberately simplified because, pixel art, the machines that we're sort of emulating here, if you will, are, kind of the 8 and 16-bit era game consoles. And those had pretty limited color palettes and things like that. So you're not going to be making like Crisis or Fallout or anything in this. I don't know. Actually, you could probably do a pretty good Fallout game. It just wouldn't be all high res. So anyway, okay. So we got the background image set. All right, that was easy. And then scroll background. So the scroll background here, if we throw that in, and it happens to already have the correct numbers in here, and you'll notice down in our preview window what's happening to the scrolling. Yeah, it's going kind of sideways, and that's because we've got Vx and Vy are both -50, so that's why it's scrolling down into the right, because the image is scrolling up and to the left So obviously that's not what we want. So let's just change Vx to 0 and Vy to, what did it say, 10? Okay, so, and then if we go back to our thing, right, it, looks like we're scrolling the, I guess it depends on your perspective, how we want to think about this. The screen image is scrolling down, so it makes us appear as if we're scrolling up, okay? And one thing about the coordinate system in graphics that's going to maybe sort of drive you guys crazy, and we'll have to kind of remember to always double check that we're doing the coordinates the right way. So in old school computing, like we're talking back in the 70s, right? If I wanted to put a coordinate system on the screen, so I could say, all right, this X location, this Y location. Well, the first thing I got to choose is where's the origin, right? And where would be a good spot to put the origin? In the dead middle would be a logical spot, right? That's not the only logical spot. If you think about like actually building physical objects, what would be another possibility? Yeah, one of the corners, right? And the choice was the top left corner. Okay, that's fine. And which way should the x-axis run? Obviously horizontally, but which way should be positive x and which way should be negative x? Yeah, that makes sense, right? That's just like it is in math. We'll make 0 be the top left coordinate's x coordinate, or top left point's x coordinate, and as it's positive, we'll go to the right. Okay, makes sense. What about the y-axis? Positive goes down, okay, in old school graphics, okay? And that's, of course, backwards from math class where positive goes up, okay? And is that mildly annoying? You kind of get used to it. It's not the end of the world. And that's just, I mean, it made sense for computer graphics back in the day, okay? Now, where this really gets annoying, and obviously we don't really have to deal with this here, is when we start getting 3D stuff in. Because then where do we put the z-axis? Well, if x and y are in the plane of the screen, then the only thing that makes sense for the z-axis is coming out of the screen or kind of going into the screen. So sort of thinking about depth. And the positive z-axis was defined to be coming out of the screen towards you, right? So that things that had a higher z value would be in front or appear in front of things that had lower z values. Okay, what that means though is that the coordinate system is a left-handed coordinate system. And in math class, what do? We do a right-handed coordinate system. So all the formulas and stuff that you learn in all of your different math classes and stuff, you have to switch them to sort of their left-handed variant, which drives me insane because I don't know, how many of you are left-handed in this class? Get out. Okay. Yes, you are the literal devil. Yeah, it's just backwards from what you're used to in math class. And what that means is that, at least in my case, right, I've been doing math in right-handed coordinates for my essentially entire life. And so when I'm trying to do stuff with computer graphics, well, I have to mentally switch everything rather than just always doing it this way, right? So if I had a time machine, there's many things I would do with it, right? Um, dealing with Hitler, um, taking a sports almanac back with me, things of those sorts. But the other things I would do is go back to certain moments in mathematical history and say, do it this way, not that way. Just trust me, and then make the future nice for everybody. Yeah. So anyway, I don't know. Maybe some of you guys would like me to, do to famous mathematicians what I would probably also do to Hitler. And so anyway, Okay, so we've got the background scrolling going on, and obviously right now these two numbers are hard-coded to specific things, but if I had like multiple levels or something, does the scrolling have to be the same for all of them? Of course not, right? So we could have scrolling upwards or downwards, or we can change the speeds, or right, we've got control over all of that. Okay, so great. Okay, now for two things. So I think last time we talked about that a sprite, right? Basically, any object in this game that the player can interact with or the player himself, these are all sprites. Okay, so it's just an object that possibly has some art attached to it, that possibly has movement controls and other properties, but it's just an entity in this game world. Okay, now our player, right? We obviously need to have a player of some sort. Okay, but we need to, before we can actually have a sprite in the world, we need to sort of create it. Okay, and under this one, we'll do, okay, set my sprite to sprite blank of kind player. Okay, so there's several things we've got to specify here. First is, what is the name of this object? Okay, it can be whatever we want it to be. The default is just my sprite. Okay, but obviously we could change that to be whatever. Okay, and then we're going to set it to be sprite, and then this little box is where we'll put the art that's attached to that sprite. Okay, and then of kind player. So this is the object oriented part. Okay, that not only does every sprite have an existence and a name, but it also has a type associated with it. What kind of sprite is it? Okay. Now, for our player sprite, it makes sense to make this a sprite of kind player. Okay. Now, when you first load this up, it's got 4 categories that are sort of predefined for you. That would be kind of common things you might use, like projectiles, food, enemy, but we can add as many different kinds or categories as we want. We could have power-ups, we could have a boss type that's different from regular enemies in some way, whatever you want, right? The sky's the limit here. But what this means is that we can, for example, if the player touches, or say 2 sprites touch each other, we will be able to determine what to do based on that. So, like, let's say that you're a player, your sprite, and your player sprite overlaps with a power up. Well, what about if it overlaps with an enemy? You should probably do 2 different things based on whether or not it overlaps with a. Okay, so what you're doing there is you're saying, okay, I want to know not only who did I overlap, but also what kind of thing was that. If it's an enemy, maybe I do one thing, like deduct health from the player or blow up the player or something like that. Or if it's a power up, then I might say, okay, well, what kind of power up is it? Is it a health power up or a fuel power up or one of those things where it like, changes the way that you shoot so that now you've got like multiple beams or whatever, right? So, but this gives us a basis for knowing what kind of objects we're interacting with. Okay, so does that kind of make sense? Okay, so in sort of big CS parlance, this is the idea of a class. The kind is a class, and then our particular player sprite, the specific one we are about to create, is a member of that class. Okay, or an object within that class. But they call it kinds in make code just for simplicity, right? I mean, because again, think about the audience here. Who are they? Right. This is designed for children and beginner. Well, it's designed for beginners, but who are beginner programmers? Kids or college students that are taking this for a distribution class. Okay. Which, yeah. So, but obviously, I can expect way more out of you guys than I would kids. Although, did anybody use Scratch when they were in school? Yeah. So, I used to use Scratch in CS101, and that was before this class existed. And it's a perfectly good language. It's got some limitations compared to MakeCode, and it's got a few other things that are nicer than MakeCode, but whatever. And one of the things that I would do with the 101 class usually in the spring when we would do this, it'd be like, oh, I don't know, sometime in April when we were doing the Scratch stuff, and so they had to make a simple video game. It could kind of be whatever they wanted. And then we went to the Carnegie Museum, which is the kids' museum in town, and set up a bunch of laptops and invited basically everybody who's a sixth grader or below in the entire county. And they all, no, not all of them, but a lot of them showed up, and they'd go from station to station playing all the games. The best part, though, was when the time that Hartnett brought his kids. You guys all know Professor Hartnett? And Henry sat down at the first computer, played the game, and was like, oh, no, you shouldn't have done it this way. And opens up the code and starts changing stuff around, and the guys are just like, yeah, he was like 10 at the time. It was really hilarious. Okay, so my sprite of Sprite, and then we need the art here, and we want the rocket ship. So which one, I guess, is the rocket ship? Are they named here? Stealth, blue rocket, fuel, dart, rocket. Okay, that one. Okay, so this chooses, of course, the specific art to go with our sprite. A sprite technically does not have to have graphics associated with it, although for the most part, is it probably a bad idea to do that, right? Now that said, if you wanted to do like, okay, so I'm thinking of like a Final Fantasy game where you're walking around in some sort of overworld, and when do you get triggered by enemies? It's not like you see them until the battle starts, right? You're just walking around, and then randomly at a certain spot you get drawn into a battle. So that actually might be an instance where having an invisible sprite would be a good thing, right? That it's just kind of moving around the map, and if it happens to run into you, then bam, you're in the battle. But okay, whatever. All right, so we've got the thing, and then we need to set the movement. So this is the controller, and we'll just say move my sprite with buttons. And it doesn't tell us to do this, but let me go ahead and mention it. If I hit that little plus, it gives me the option to specify what the vertical and horizontal speeds are for my movement. And so, like in a space shooter, for example, you could make it so that you could only move left and right, and you can't move up and down. Or in this case, we have sort of equal control over each direction. Okay, so great. Now, if I go into the simulator here, and then I can control it either with the WASD keys or the arrow keys, sort of equivalently enough, right? Okay, so there's a couple things to notice here. One is I have equal range of movement in both directions. The second is I can move off the screen sort of indefinitely. Okay, so that's obviously something we would want to fix, is not being able to go off the screen. And yeah, okay. So is that good? Okay, so we've got that, and then here's the screen part, right? So one of the things that's nice here about MakeCode is that single block will keep the thing from going off the screen. Okay, now you see the little toggle there that's an on-off. That's a pointing object, so that actually could get replaced with a variable. Okay, so like for example, maybe in like I don't know, like a cutscene or a certain level, right? Maybe you actually do want the player to be able to go off the screen a little bit. You could turn that off at the appropriate time and turn it back on at other appropriate times. Not sure why you'd want to, but you've at least got that option. Okay, so let's think about, though, it's really nice that this has the stay in screen, and this is a single instruction from our point of view, okay? But let's think about really how this would work. So like for those of you who did Scratch, there is no obvious thing like this in Scratch, okay? So let's say that we did not have this this sort of individual control. How would we program the idea of being able to stay on the screen? Yeah. Right. Yeah, so we'd have basically four cases to worry about, right? If the player's x coordinate was bigger than one thing, well, let me do this from your perspective, bigger than this or smaller than that, then that would be defining the outsides of the screen in the left-right direction. Turn off the player movement if they're at that end. But don't turn it off completely, because you'd still want them to be able to move this way if they were against the left-hand screen, and that way if they were against the right-hand screen, okay? And similarly for the top and the bottom, you'd have to detect, are they against the top or the bottom? If so, only allow them to move this way or that way, okay? So does that kind of make sense? Now, all of that is basically encapsulated in this single command such that you don't really have to worry about it. That was real kind of them, okay? But let's say, for example, that you wanted the player to be able to go off the screen in the X and Y direction, but not, or sorry, the X direction, but not the Y direction. This command isn't going to do it for us, because this is going to do all of them, okay? So in that case, we'd have to like manually code this sort of thing. Okay, so does that make sense? Okay, so now just to test it here, right, I'm sort of limited, and my movement is limited such that when my left-hand edge touches the left-hand edge of the screen, I can no longer move that direction. Now, what about if you wanted to have a little bit of slop here where you could kind of go half off the screen but not fully off the screen? Is this built-in command going to do it, or would we have to manually do it? So like where my sprite could, like, half of it could go off the screen, but only half of it. Yeah, I'd have to do all that manually. Okay. Okay, but this is good enough for now. Okay, so let's keep going, and we're done with that one. Okay, and all right, any questions on that one? All right, pretty straightforward. Yeah, obviously this is going to get a little bit more complicated. Yeah? All right, so let's go to the next one. All right, and we'll just keep the code from everything that we've done before. So now we want to do the shooting part, okay? And this is where we will be spawning sprites of a different kind and attaching their creation to some sort of event within the game. Okay, so works. Okay, fine. Everything's fine. Okay, so on controller, right, we've got the move sprite with buttons that we already saw. We've also got the on A button pressed. Okay, now this is a separate object from, or separate chunk of code from the on start piece. Okay, so the on start piece, everything that's within that will execute precisely once when the game actually gets started. Okay, and if it will only get re-executed if I reset or restart the game. Something like this event, the on A button pressed, anytime the A button is pressed, whatever's within this will get executed. Okay, so if I mash that A button, then it's going to, whatever's inside here is going to happen over and over again, which could cause issues. So we may have to kind of worry about that. Okay, so let's, under sprites, we're going to create the projectile. Okay, and let me scroll over here. So we've got set projectile, that's the name of the object, to be a projectile, which is a a projectile is a specific category of sprite where it has sort of a fixed velocities and stuff. We could make sort of our own projectile category, but whatever. Okay. All right. So what do we need? We need some art to go with this. And I think it said pick the dart for this one, which is, I think, that. Okay. And now, where is this thing going to start out in the world? So where is it getting shot from? In our space shooter game, what would make sense? Yeah, starting at the player. Okay. But like, let's say, for example, I wanted to have a power up that allowed you to shoot like a double barrel kind of thing. Well, then would I want both of them to start at the player? No, I'd want them to start like slightly to the left and slightly to the right of the player. Okay, so I might have to adjust that a little bit. But okay, whatever. And my sprite is the name of where this thing is going to start. And then we also have the option to set the velocities at which this thing runs. Okay, so if I go up to my little tester and I hit the A button, which is bound to space in the unless you have like an actual controller plugged in. All right, so what's happening to my projectiles? They're not going the right way. Okay, because I set them to have Vx, Vy 50-50. Okay, and so what would be more reasonable here? Vx 0, and how about Vy negative something? You know, let's just try negative 50 to start. Okay, and of course, why is it negative? Because of the weird coordinate system, right? It's going up, and that's negative in our graphics coordinates. Sorry. Okay, so does that look reasonable? Okay, maybe it's a little slow. Why don't we speed this up a little bit? That's more pew-pewy, if I say so. Okay. All right, is that nice? Good. Okay. Now, one thing that's nice here is you notice when I clicked on this, it actually told me what the units associated with this were, and they're in pixels per second. Okay. So that gives you a sense of scale here as to what these velocities mean. Is that everything, if the coordinates are in pixels, then the velocity should be in pixels per some unit time, and seconds certainly makes sense in a video game context, just because things are happening pretty quickly. Okay, good. So, all right, so what's next? So we've made the thing shoot, okay, and we fixed the velocity, okay, and here is basically where it's describing the coordinate system and explaining, of course, the whole issue, right? So we've already kind of talked about that, but any questions about sort of the physics, if you will, here? You guys will get used to it, obviously. Does it kind of make sense? I mean, once we accept that the coordinate system is weird, everything else is just sort of, well, okay, that's just what it is. Okay, good? Yeah? Okay. All right, so blah, blah, blah. And so we've create and we've got the thing moving kind of roughly the way that we want it. And now let's make it look cool, okay? So so let's do here under the spray effect, okay? So this is this one, and I'll put it here, and we're going to change this from my sprite to projectile, okay? And we'll make the spray effect, and then we can adjust this to 100 milliseconds. If we have too many effects going on at once, it'll start to slow the game down. Okay, so we don't want to overdo it. Okay, so now what happens when I shoot? You see that little sparkly business going on next to my dude? I don't know. What do you guys think? Does that look cool or lame? Yeah, what I mean, everything is going to look lame that we create because it's all pixel art. But um, yeah, so we can do some sort of basic effects kind of stuff there. Okay, so fine, that's whatever, and then we're done with that part. Okay, so any questions on that? That one was pretty straightforward. All right, so let's keep going. Namely, we want to have enemies, and this is where we're going to have to start to worry about the kinds and interactions. So, okay. All right, so let's start. So let's keep all our code, okay? And so here's sort of the idea as to what we want to do. Well, looking at the preview here, what do we want to have happen in our space shooter? We want to have enemies get created, okay? And the enemies are going to be moving downwards towards the player. Okay, great. And what else should be true here? Like, so we need to create enemies. How should we create them? Okay, we'll create a sprite. We'll call them enemy or whatever, and they will be of type enemy. Okay, so we're now instancing a new kind of thing. Okay, where do we create them? Top of the screen or maybe slightly above the top of the screen so it looks like they're kind of coming in. Okay, do enemy sprites have to stay on the screen? No, not necessarily. Although, what would happen once an enemy gets, say, down here? Yeah, we should probably either delete it because it's no longer in the game world. And what, like, let's say you dodge 50 enemies. Do we want to have to keep track of 50 enemies down here that you can't even do anything to? No, it'll start to slow the game down. So we could destroy them if they get down here, okay? But also, we should be able to destroy them if they come in contact with a player projectile, okay? So this is where the interaction of kinds matters. If a player overlaps with an enemy, we should do something to the player. If a projectile overlaps with an enemy, we should do something to the enemy, right? But there we're making the decision based on what kind of projectile or what kind of sprite are interacting. Okay, good. Okay, so so we need to continually create the enemies. Okay, and under the game thing, we now have this new piece called OnGame. Excuse me, OnGame update. Okay, so this is going to run every unit of time that's specified by the little drop down. Okay, which can be 100 milliseconds all the way up to 5 seconds. You want to use this particular block very sparingly because if we start to use it too much, particularly if we also make it do something every 100 milliseconds, we might be introducing more things to be processed than the game engine and the computer can handle, and it'll start to slow things down. Okay, so let's pick, say, 2 seconds here. And of course, you can also type. You're not limited to these 6 options. You can type in that little box, okay, or even make it a variable for that matter. Okay, so if we make this every 2,000 milliseconds, that's 2 seconds, right? And does that seem like a reasonable frequency for how often the enemy should appear? Yeah, roughly. Okay, so obviously we could change that, but we'll do that. Okay, so we need to create these sprites, okay, and uh, the way that the uh, well, okay, we don't have to do it this way, but the way this particular tutorial chose to do it was actually to make the enemies also projectiles, okay, um, which I personally wouldn't have done, but whatever, let's run with it and see what the consequence of that decision is. So what's maybe the good part about doing that is that we can set the velocities immediately, okay? And we can also set okay, where these things come from. Okay. All right. So what do we want to do? Let's rename this the type here, or sorry, the name to my enemy. Okay, whatever. It's going to be a projectile, and we'll fix the velocities in a second. Okay. So let's take this and let's get some art for it. And which one sort of is the spider? Dart, dart, fuel, blue rocket, stealth. Huh. This one? Oh, there it is. Okay. Yeah. Okay, good. Right. And then what about our velocities here? So what should our velocities be? X should be 0. Y should be what? 50 seems reasonable. Let's test it out. Okay, so does the speed look reasonable? Okay. What about the location? Now, location looks ridiculous because where are they coming from? The origin. Okay. So we've got that to fix, but at least they're getting created, and they're getting created every 2 seconds. Okay, so that looks okay. And what we want to do is we want to create them and then move them someplace else. So if they initially get created at the origin, we can, let's see, where is this going to be? Set this one here. Okay. I can set the x coordinate of that object to something. Okay. Now, by default, where is it? It's 0. That's the left-hand edge of the screen. What should we make it? Yeah, okay, so let's say we set the x to 25. Okay, let's test that out and see what we get. Okay, so what's true now? Okay, so that's better. Okay, but is that quite what we want? What would be even better? Yeah, some sort of random number. Okay, between, say, 10 and whatever the right-hand edge of the screen minus 10 is, or whatever, right? Okay, so now we need to do random number stuff. Okay, so we've changed that. Okay, and then we want to do the random, and that's under math. Okay, and so if I plop, so basically I've got that thing, and I'm going to plop it where that round object was, and you saw how it had the little red dot, and sort of drew a line to it. That's how you know which little socket you're about to plop this thing into. Okay. Now, in this particular case, that's not all that horrible because there was really only one socket. But as we'll see with some of the other things, there might be multiple sockets, and sometimes you just have to kind of tweak it a little bit for it to go into the right socket. Okay. But you guys will figure that out. Okay. So is 0 to 100 what we want? Or sorry, 0 to 10? I mean, that's what it defaults to for the randomizer, but what would maybe be more reasonable here? I mean, it tells us what to do. Okay, it says 5 to 155. Okay, where the heck did they pick 5 and 155 from? Yeah, it's essentially the width of the screen. So what's the total width of the screen in pixels? It's 160. Okay, and so by doing 5 to 155, we're making it so that taking into account whatever the width of the sprite itself is, so that the whole thing is on the screen, or at least mostly on the screen. Okay, does that make sense? And on the subject, if the horizontal range is 160 pixels, what's the vertical range? It's not 160, it's 120. Okay, and Now, how do I know that other than knowing this language? What's the ratio between the width and the height on, basically every computer that's in this room or TVs? 16 by 9. Okay. And that has been the case since the, I don't know, mid-2000s, roughly. But in the 90s, when 8 and 16-bit game consoles were the thing, what were the ratios on the TVs then? It was 4:3. Okay. And now occasionally your computers will be 16 by 10 instead of 16 by 9. But TVs, if you go out and buy them, pretty much any TV is going to be 16 by 9. Now, it might be 8K, but the ratio is still 16 by 9. I don't know. Anybody have an 8K TV in their dorm? No, because you guys are college students, right? Yeah. Okay, so that's the ratio here, and this game engine respects that ratio, so it's still 4:3. So 160 to 120 is 4:3. Okay, great. Okay, so in this case, we're not twiddling with the y coordinate of the enemy, but we certainly could if we had wanted to. Okay, so we got that, and now let's just look at it and test it out and make sure that this looks reasonable. Oops, let me reset it here. Does that look roughly reasonable? Yeah. Okay. Okay, so that's good. Yes, sir. Yes, they do. Okay. Good. Yeah. So let me zoom out here. If you imagine that we have a created game, an entire game that we've finished, right? What's going to be true is that there's going to be a lot of these blocks, and it will start to get a little messy. Okay. That means a couple of things. One, it's incumbent on you to try and keep things tidy and not have lots of crap overlapping and keep things in rows and stuff. But one thing that's nice is if you right click format code, it will kind of auto arrange everything so nothing's overlapping, and kind of try and tidy up the workspace a little bit for you. Okay, so this is, and as you guys will discover, this is one of the limitations of block or graphical based code, okay, is that it gets very difficult to see all of your code at once, okay. This is one thing that I think actually Scratch does better than MakeCode, because with Scratch, every sprite has its own palette for code. Okay, so what that means is that you can keep things organized and have code that deals with the player attached to the player, and code that deals with the enemy attached to the enemies, and not have to, worry about mixing the two. Now, the downside to that is then you have to remember where the hell you put stuff. Okay, and it can turn into a big mess. This will also turn into a big mess. It's just sort of a different kind of mess. If you've got like piles of hundreds of papers and there's piles on each of the tables in the classroom, that's one kind of mess. If you dump all of those papers into a big pile on the floor over there, it's still a mess, right? It's just a different kind of mess. Okay, so yes, this is definitely one of the limitations of block-based programming, is that it does make the sort of housekeeping a little bit more irritating. Okay, but c'est la vie. Because what's the alternative? Yeah, writing everything in text-based code, which is at least initially more difficult. Okay, you have to remember what all the commands are. You have to make sure that you have parentheses in the right spaces and all of that kind of mess. Okay, and then if you look at the code, you're looking basically at just a giant wall of text. And if I were to give that to a 10-year-old, what are they going to do when they look at it? Probably, right? They're just, and hell, maybe you guys would too, right? It's kind of like, uh, particularly those of you who aren't freshmen, who've been around for a while. Have you guys ever had to, you're in a class where like you have to give presentations to the class, and there's always that one group that has the PowerPoint that has way too much crap on each slide. You know, like they put like, there's so much text, they might as well have War and Peace on one slide, right? And what happens when that stuff hits the screen to your eyes? You're just like, you know, you might as well have a frosted glass for eyeballs. Okay, so yes, that's the downside to real code, is that unless you're used to that, then it's sort of you know, like pouring battery acid straight into your eyeball. Okay, yeah, you guys know The Simpsons, right? Ah, the goggles, they do nothing. No. Uh, yeah. Okay. You guys are pathetic. Okay, so yeah, Sam's point here is completely valid. Uh, with complex games, this will start to get to be kind of a mess, and so if you're smart about trying to organize things in a logical way, then it won't be so horrible. Okay, but just keep that in mind. Okay, so let me zoom back in here so we can see what we were doing. Okay, so where were we? The enemy movement looks pretty good. Okay, so are we happy with that? Okay. Okay, so the on-game update, okay, and this is why they did the projectile thing. I kind of see why they went this direction. So what I can do is if I create, so originally the my enemy is being created as if it's a projectile, okay, which is a specific kind of object. Now, one thing that's kind of cool is that the type of object is not actually a fixed quantity for a given sprite. I can change what category something belongs to on the fly, okay? And so what I'm going to do is I'm going to change the enemy from a projectile to a type enemy, okay? And I could call this whatever I want, obviously. Now, you might say, why not just create it as an enemy to begin with? And I could have done that, okay? But if I wanted to create it as an enemy to begin with, I would have done this first block, but then I would have to separately add in the movement command, okay? So it's sort of 6 of one, half a dozen of another in this way. But that was a choice that whoever wrote this tutorial did. Um, I think maybe one reason that they deliberately did this was explicitly because by doing it this way and making the enemy or making the thing change from being a projectile to an enemy, it's demonstrating that you can change the type of a sprite while the game is running. Okay, and so maybe that was a good decision. I don't know. What do you guys think? Maybe, right? I mean, I guess if there's anything here to learn, is that or sort of the lesson that we could take from this, everything you do is a choice, and that choice is going to have consequences, right? It might make 10 things that you're about to do a whole lot easier. It might make those 10 things you're about to do a whole lot harder, but something 10 minutes later a lot easier, right? And as you guys get used to this and we, go through and do examples of things, it'd be kind of like beginning chess players. So anybody play chess like seriously? No. Okay. But if I handed you all chess boards and I played against you and I'm a grandmaster, which I'm not, so don't worry. What's going to happen? You're going to get annihilated. But in particular, right, you're not going to be drawing from any experience, and you're also not going to be thinking like 5 moves ahead, right? Whereas the chess champion is not just thinking about the move they're about to make, but what the board might look like 5 moves down the line, right? And to some extent, this programming is sort of like that. If you make a choice now, do you necessarily know what the consequences are going to be 5 moves from now? Not yet, but after we do more of this, you guys will start to get that intuition. Okay. Okay. So we've changed the enemy to actually be of kind enemy. Okay. And the reason that that's going to be important is for the overlapping stuff. Okay. So so I'm going to have a new event here. Okay. And this event is going to trigger anytime 2 sprites overlap. What kind of overlap do I care about? Or kinds, plural. Okay, the overlap between an enemy and the player. Okay, so let's do that one first. So player overlapping with enemy. Okay, what should happen with the player overlaps an enemy? Die or lose life or something along those lines, right? Okay, so in this case, it's we'll do the 2 things. We'll deduct 1 point of life from the player, and we'll destroy the enemy. Okay, so under scroller, or not scroller, it'd be under game, where is it? Info, okay. Change life by -1, okay. And then under sprites, I'm going to destroy this. Okay, now, if I destroy my sprite, who gets destroyed? What is my sprite? That's the name of the player's spaceship sprite. Is that the thing I want to destroy here? No. What do I want to destroy? The enemy, okay? But not just any enemy. I want to destroy the one that I just ran into, right? Because is it possible there's multiple of these things on the screen at once? Yes, okay. So how do I know which enemy I just ran into? That's where this sprite and other sprite here come in, okay? So think of this sprite, this red bubble, and that other sprite, red bubble, as placeholders, okay? There's nothing called sprite or other sprite. But if I plop the other sprite in where it says my sprite, what's going to happen is, and let me delete this guy, right? It's going to say, okay, 2 things just overlapped. I'll call temporarily the player thing is the sprite. And the enemy type that it ran into, whichever actual one it is, I'll call other sprite. What do I want to do to that other sprite? Okay. And so this is how, like, let's say that we had more than one enemy on the screen. If I did not change that thing from enemy to other sprite, it would destroy all of the enemies rather than just the one that I ran into. Okay. Now, might it be possible that you want to do something where it destroys all enemies? Okay. Like, what would be a good example of when you might want to do that? Yeah, like special ability, or like you guys ever played Star Fox or any of the stuff in that series, right? So in Star Fox, you've got your laser, your pew pew, and then there's also like the bomb that you can do that destroys all enemies currently on the screen. Okay. And then obviously more enemies are going to come, but if you're being overwhelmed, right, you can use that to save yourself. So yeah, so you might want to destroy a whole lot of stuff, but in this particular instance, we only wanted to destroy the one thing that we ran into. Okay, does that make sense? All right, so let's test it out and make sure it looks right. Okay. All right, so far so good. Okay, so two things happened here. One is how many life points do I start off with by default? 3, okay? Now, notice that it didn't actually display any of that until after I took damage. Okay, we could fix that. But also notice what happens when the life equals 0. It gives us a game over, like it literally ends the entire game. Okay. What this means is if you wanted to do something like, oh, I don't know, where your life equals 0 and then there's like a retry menu that pops up or something, we'd actually have to manually do some of that without using the built-in life variable. Okay, that's okay. But for now, this is fine. Okay, so are we happy with how that looks? All right, so now let me click this plus here and show you one cool thing. So let me do the, let's do rings effect. Let's try this. Okay, so I don't know if that looked cool enough or whatever, but, or maybe we could try this one. So you see the little effect that it's doing when it's destroying the enemy, just to make it look cool, right? Okay, great. Okay, good. All right, so we've changed that. We've dragged the other sprite thing in here so that we're destroying the right thing. Okay, and then what's the other type of intersection that we wanted to contend with? Yeah, projectile hitting an enemy. Okay, so we essentially want to duplicate what we've already done here, but this time it's not going to be a player, but rather when a projectile overlaps with an enemy. Okay. Okay. So when we do that, what do we want to destroy? Both the enemy and the projectile. Does that make sense? Yeah. Okay. Now, we would. Did we have to destroy the projectile? No, but does it sort of make sense that we would? Yeah. Okay. So if you were trying to do like a laser beam, for example, then maybe you wouldn't want it to destroy. Um, but okay, so we'll have 2 of these destroy blocks, and we want to destroy both Sprite and other Sprite. Okay, and that's going to destroy both the projectile and the enemy that it ran into. Okay, and then we can put effects on that if we want, but let's just run it and make sure that it looks okay. Okay, so look good? Yeah? Okay. All right, so that's nice. And yeah, we could add effects to it if we wanted, but that's just making it look cool. The functionality works. Okay, what else could we do here? Well, it's a game, right? Games have scores. Okay, so under info, there's also a score variable that's built in. Okay, and we can uh, change the score. Okay, so let's run that and see what happens. All right, so as I shoot them, now notice what happens up in the right. Yeah, it's going to not only go up, but it starts displaying it. Okay. And the score defaults to being displayed at the top right corner, although that's certainly not a necessary thing. Um, yeah. Okay. So we've got a score in here. And we could use the score mechanic for stuff because, well, like, let's say, what might be a good mechanic to have every time you score 10 points? Just, think. Just make something up. Okay, either a boss comes along, or you get some sort of power up, or whatever, right? Like you get an extra life if you get 100 coins, like in Mario, right? So you could do stuff like that based on the score, or maybe you make it so that, for example, here are enemies. Do they have health associated with them? No, right? It's a one-shot thing for the enemy. Could we change that and make it so that enemies, maybe there's like a new kind of enemy that has 2 health points and takes 2 shots to kill? Yeah. Okay. So we can really start to complicate this up, but obviously we don't want to do it all at once. Okay. So now let's see, where are we? Okay, and we're done with this one. Yay. Okay. Questions? Yeah. Good. Okay. So what's next? Well, let's keep the code. So the next one is concentrates on the special effects. So you see the little thing underneath our rocket ship that, well, maybe it's a little hard to see here, but that you see the like flames that are underneath, right? Is that kind of cool looking, right? So this is going to be an animation, all right? And so we played it. Okay, great. And now the camera shake. Let's do here. So this is under scene. Okay, and I'm going to put this when we intersect with the enemy. Okay, all right. So now, oops. So you see how it sort of shakes? Yeah. And you could imagine if you were doing this with like a Switch or a modern game console where it's got the little rumble packs in it. Yeah. And on the subject, actually, what was the first video game console that you guys all played when you were kids? What did you have as kids? A Wii? GameCube? Okay. How old were you when you 10? Okay, so like, do you remember like, oh, you got the GameCube for Christmas? This is awesome. Or do you have older siblings and maybe it was a hand-me-down console? Yeah. Anybody else have actual memories of? How old were you? Okay. Yeah. What was the first game you played on it? Animal Crossing? Oh, of course. That was going to be my next guess, right? Pokemon. So I knew I officially got old when I knew nothing about Pokemon, but my students knew everything about Pokemon because Pokemon came out when I was, I think, 16, right? So I was in high school and then college. Like, I wasn't playing Pokemon, I was playing Counter Strike. Okay. Yeah. Whereas when you're 8, what kind of games are you playing Counter Strike when you're 8? No, you're playing Pokemon, Yu-Gi-Oh, and I don't know, Magic cards. Did anybody do that back in the day? Yeah. Or, um, or like SpongeBob. You guys probably all watched SpongeBob when you were little kids, or many of you. Yeah. Never watched an episode of SpongeBob in my life. And so, like, when you guys all make jokes about Squidward or whoever, I'm like, got me. Don't know what the heck you're talking about. So, okay. So yeah, so let's get back to it. We got some camera shaking. Okay, yeah, that looks cool. Great. What else do we have? Okay, so like I think I mentioned last time, or maybe it was on, no, it would have been last time, because what did we do on Tuesday last week? Yeah, the very first day. What did we do? Yeah, we played cards. And you guys were probably like, this class is going to be awesome or lame. Okay, so yeah, I talked about that there's some advanced like plugins that you can use, right? And we're about to use our first one, which is to say on the animation, okay? An animation for my sprite, we're going to plop this in over, and to Mr. Kennett's point, this is when this starts to get a little messy, right? Because I'm adding things to blocks that already exist. Okay, I'm going to add an animation to here, okay? So I create the sprite, and then I'm going to say how to animate it. Okay, now, notice over there in the preview what happened to my sprite. Can you see it? I mean, I know it's a little tiny. You probably can't see anything. Right now, it's invisible, okay? And the reason is because I haven't chosen my animation frames. Okay, so if I go to the assets and I pick my spaceship, which is what, this one? Okay, then what an animation is really just a sequence of images. Okay, and if I change from one image to the other over a relatively fast time scale, it appears to you as if it's animated, right? And I say relatively fast time scale here because, well, what sort of time scale would you need between one frame and the next for it to be realistic? Yeah. Okay. So on the order of, 20 to 30 times per second at roughly. For pixel art, this one will be every tenth of a second, so 10 frames a second. Um, you wouldn't want to play a video game in 10 frames a second, but if only specific animations were in 10 frames a second, that's probably good enough. Okay. Obviously, it's going to depend on the game. All right. And so here, right, all I'm seeing is I can go from one image to the next. In this case, there are 5 frames, and of course, I can add as many of these as I want. Okay, um, and it's going to animate those at, and we can choose the rate here. 100 milliseconds per frame would be 10 frames a second. Okay, and then let's run this and see. Okay, so what do you notice about the animation? Is it animated? Why not? Because I didn't tell it to loop. Okay, so now what is it doing? Yeah, so when it hits that last frame, a tenth of a second later, what does it do? Goes back to the first one. Okay, and then it just keeps doing that over and over again. And the pointy thing here, again, can be tied to a variable. Okay, so for example, let's say that you had like a cutscene or something where your ship like is landing on a base. Well, wouldn't it make sense to switch the art to something where the engine's off and it's not animating, right? That'd be logical. You'd have to create said art, but whatever. Okay, so we've got our frames, we've got our interval, we've got whether or not it loops, and then of course, which object are we animating? We could animate lots of different objects, although be careful, don't try and do too much at once because it'll start to slow down the game. But get the idea? Okay, so that looks good. And then we've got the animation. We did that. Try it out, see how it looks. Okay, let's do the same thing for the enemies. Okay, and so let's see. This is on the game updates, which was here. So we're going to animate. We're going to animate my enemy, which was the enemy that got created. And then we need to choose the art that's associated with it, and that was this one, okay? And now let's try that. Oh, and then let's turn on looping there and hit next. Okay, so let's see how that looks. Okay, look reasonable? Yeah? Okay, great. All right, so that's pretty cool. All right, so the animation's not too bad, but what's going to be the hard part of actually doing animation? Huh? Yeah, exactly. If in this case they had art pre-done for us, okay, and that's fine. Um, so uh, but and okay, in this case, what really were we animating? It was just the flames at the bottom, or like the engine. Is that difficult to maybe kind of do manually, right? Particularly if you already had the spaceship to start with, right? That's not going to be that horrible to draw that art, okay? Um, Now, I don't know about you guys, but I am not an artist by any way, shape, or form. I suck. There's a reason I became a mathematician. Okay. Um, and so, yeah, if we wanted to draw this art, we'd have to kind of futz with it. Now, the good thing or bad thing, depending on how you want to look at this, is how many colors do you have to work with? Not many, you know. And what kind of resolution are your graphics going to be at? Well, if the entire game screen is 160 by 120, right, what are your individual sprites going to be? Like on the order of 10 to 20, right, in possibly each dimension. Okay. So it's not like you got a whole lot of pixels to work with here, which is both limiting but also nice, right? Because there's not a whole lot you can do. Um, yeah. So and the animation part is going to be obviously the tricky thing because if you're not good with the art, well, sorry, um, unless you can find somebody else's assets to rip off. What is that when we steal assets? That's called plagiarism, right? And that's bad. Okay, you shouldn't plagiarize because it's bad. Yeah. Okay. I'm being a little bit facetious there because it is okay to use other people's art. When really does it become plagiarism? Like, what's really the difference there? Yeah, exactly. You pass it off as if it's your own work, right? But if it's something that somebody has created and said, "Hey, here's this thing, use it for whatever you want," and you use it and you attribute it to them, well, then that's cool, right? Um, so uh, now the one thing I guess that maybe should go without saying is any art that's built into MakeCode, like within the game engine, you don't have to cite it; it's already there, right? Just that'd be silly. Okay, but if you start using other people's stuff, it's only reasonable to cite it. Okay. Um, And then, now this isn't necessarily plagiarism, but what about if we took a bunch of Super Mario art and put it in here? And even said, yes, this is Nintendo's art. Is that plagiarism? It's copyright infringement, which is a different animal, right? Okay, so, huh? Yeah, exactly. Now, if we started selling this for $1 million, right? But probably nobody would notice that we'd even done it. And there are Okay, so copyright is, there are educational exemptions for certain things. So, like, for example, if you wanted to excerpt a quote from a book in a paper you're writing, is that copyright violation? No, of course not, right? Um, assuming you're cited and everything properly, right? Excerpting of things up to a reasonable percent for academic use is perfectly reasonable, right? So if we, used a little bit of Mario art here for demonstration's sake and whatnot, it's when we start trying to make money off of it or we're going outside the educational kind of carve-outs within copyright law that we, are in trouble. So, okay. Anyway, so what have we done? Yeah. Okay. So what do I want you guys to do for Thursday? How about you finish this tutorial set? Sound good? All right. Okay. And then when you finish it, think about a mechanic that's not already there that you might like to add. Okay. And so we can sort of talk about that at the very beginning. Okay. Good? All right. So I will see you guys on Thursday.